Hey everyone, welcome to another deep dive today. We're going to be looking at something that's really important to global trade and safety, and that is inert gas systems on oil tankers.
Oh, wow.
So, these massive ships that carry all that flammable oil.
Right.
One wrong spark and
Yeah.
it could be a big problem.
Big problems.
So that's where these inert gas systems come in.
Right.
They're kind of like these unsung heroes, working behind the scenes to prevent those fires and explosions by replacing the oxygen in the cargo tanks with a non-flammable gas.
Makes sense.
Pretty interesting stuff, right?
Yeah, it really is. I mean, it's a fascinating system.
Yeah.
And it's really all based on a simple principle.
Yeah.
You can't have a fire without oxygen. So by reducing the oxygen levels in the tanks, you essentially eliminate the risk of combustion.
Okay. That makes sense. But how do they actually do that?
Okay.
I mean, we've got some pretty in-depth reports here from the International Maritime Organization,
Yeah.
the IMO, and some real-world incident analyses from the Oil Companies International Marine Forum, the OCIMF.
Yeah.
And it seems pretty complex.
Well, let's start with the most common type of inert gas system.
Okay.
The flue gas system.
Okay.
Now, imagine using the exhaust from the ship's boilers.
Okay.
That's flue gas.
Right.
Now, you can't just pump raw exhaust fumes into the cargo tanks.
Well, of course not.
It has to be cleaned and cooled first.
Oh, so it's like a giant air purifier for the ship's engine.
Exactly.
Absolutely.
The flue gas goes through a scrubber, which removes things like sulfur dioxide and solid particles.
Right.
Then it's cooled down to a safe temperature before being pumped into the tanks.
So that's what creates that inert atmosphere.
Right.
I was looking at this IMO diagram.
Okay.
It's figure 1 from MSC Circ .353.
Yeah.
And it shows how the flammable range of a gas-air mixture shrinks
Right.
when you add inert gas.
Okay.
So you're essentially squeezing out the oxygen, making it much harder for a fire to start.
Exactly. And the IMO regulations are very strict about the oxygen levels allowed in the tanks.
Right.
They mandate a maximum of 8% oxygen. That's a key safety factor.
Wait, why 8%? I thought combustion needed around 11% oxygen to occur.
You're right, but that extra 3% margin isn't just an arbitrary number.
Right.
It's a crucial safety buffer that accounts for potential fluctuations in the system.
Okay.
And ensures that even a small leak or malfunction won't push the oxygen level into the danger zone.
Okay.
Think of it like a safety net for the entire system.
That makes a lot of sense.
Okay.
So we've got this clean, cooled, inert gas being pumped into the tanks.
Right.
What else is involved in this whole system?
Right.
I mean, there are all these other components mentioned in these IMO guidelines.
You need something to push the gas through the system. That's where the blowers come in.
Right.
Powerful fans that force the inert gas through the pipelines and into the tanks.
And what about those non-return devices?
Oh, yeah.
They sound pretty important.
Absolutely. They're like one-way valves that only allow the inert gas to flow toward the tanks.
Okay.
This prevents any backflow of potentially explosive cargo vapors into the machinery spaces where they could ignite.
Yeah, it's like a series of safeguards to make sure that flammable gas never gets anywhere near a potential ignition source.
Exactly. And speaking of safeguards, there's another crucial component. The deck water seal.
Right.
It acts as a barrier between the inert gas system and the outside atmosphere, preventing air from being drawn into the tanks. There are actually a few different types of deck water seals. Figures 6 through 9 in our IMO source material illustrate them in detail.
It's incredible how much thought and engineering goes into these systems.
It has to, considering what's at stake.
Right. So we've talked about how the inert gas gets into the tanks.
Right.
But what about getting it out?
Okay.
I mean, at some point, they need to unload the cargo, right?
Right, and that's where the procedures for purging and gas freeing come in.
Okay.
They're both about replacing the inert gas in the tanks with something else.
Okay.
But for different reasons.
Okay. I'm curious, what's the difference?
Think of purging as fine-tuning the atmosphere in the tank.
Okay.
You might purge a tank to further reduce the oxygen level.
Okay.
Or to get rid of any residual hydrocarbon gas before loading a different type of cargo.
Okay.
It's all about creating the ideal conditions for the next operation.
So purging is about adjusting the atmosphere within the tank.
That's right.
While still keeping it inert.
Exactly. Gas freeing, on the other hand, is a more significant operation.
Okay.
This is where you completely replace the inert gas with fresh air.
Okay.
Bringing the oxygen level back up to normal. Typically 21%.
Right.
You only gas free a tank when it's absolutely necessary.
Right.
For example, if someone needs to enter the tank for inspection or repairs.
That makes sense, but I imagine it's a delicate process, right? You don't want to accidentally create a flammable atmosphere
Right.
while you're trying to make the tank safe for entry.
It's definitely a critical operation that requires careful planning and execution.
Right.
There are very specific procedures outlined in Section 5.12 of the IMO guidelines to ensure it's done safely.
And I'm guessing they use those portable gas detectors.
Of course.
To make sure the tank is truly safe before anyone goes in.
Absolutely. No one should ever enter a tank without those readings confirming that the atmosphere is completely gas-free and breathable.
Right.
It's a non-negotiable safety measure.
And that brings us to a crucial question.
Okay.
What happens if something goes wrong with the inert gas system itself?
Right.
I mean, these are complex systems and things can fail, right?
That's where those emergency procedures in Section 8 of MSC Circ. .353 come into play.
Okay.
The first priority is to prevent any air from being drawn into the tanks.
Right.
Which could create that explosive atmosphere we've been talking about.
So they immediately shut down cargo operations and isolate the tanks?
Exactly. They close the deck, isolating valve to seal off the tanks.
Okay.
And then, depending on the situation, they might connect an external inert gas supply.
Right.
Or take other precautions to maintain a safe atmosphere until the system can be repaired.
It sounds like there are a lot of potential hazards involved in operating these systems.
Right.
It's not just about the risk of fire and explosion, is it?
No, you also have to consider the dangers of oxygen deficiency.
Right.
Inert gas is by definition non-breathable.
Right.
So entering a tank that's been inerted without proper ventilation and breathing apparatus can be incredibly dangerous.
So it's not just about protecting the ship and the cargo, but also the people working on board.
Absolutely. Safety has to be the top priority in every aspect of tanker operations.
Right.
And understanding the hazards associated with inert gas systems is a crucial part of that.
Speaking of different types of tankers,
Okay.
we've got information here about product carriers and combination carriers.
Yeah.
Do they use the same inert gas systems?
They use the same basic principles, but there are some unique considerations for each type of vessel.
Okay, I'm all ears. Tell me more about these different types of tankers and how their inert gas systems might differ.
Well, let's start with product carriers.
Okay.
These vessels typically transport refined petroleum products like gasoline and diesel.
Right.
The key difference here is that these products often have higher flash points than crude oil.
So they're less likely to ignite at lower temperatures.
Exactly.
Okay.
But you still need to be incredibly cautious.
Right.
Because even though the risk of fire might be lower, there's always the potential for contamination.
Right.
You don't want traces of one product mixing with another and affecting its quality.
Right. So those purging procedures we talked about earlier would be even more important on a product carrier.
Absolutely. And there's also the risk of water contamination.
Right.
Which can be a big problem for certain products.
Yeah.
That's why proper line draining and maintenance of drying arrangements are crucial on these vessels.
It sounds like transporting refined products adds a whole other layer of complexity to the inert gas system operation.
And then you have combination carriers, which are even more challenging.
Okay.
These vessels are designed to carry both oil and dry bulk cargo.
Oh, wow. Okay.
Which creates some unique hazards.
Like what?
Well, for starters, you have to worry about static electricity buildup in the holds.
Right.
When they're partially filled with ballast.
Okay.
That can be a real fire hazard if you're not careful.
And I imagine those hatch covers
Yes.
have to be absolutely airtight.
They do.
To prevent any leakage of gas.
Any leakage could create a dangerous gas pocket that could ignite.
Wow.
That's why frequent inspections and meticulous maintenance of those hatch covers are essential on combination carriers.
It seems like these combination carriers present a whole new level of challenges.
They do.
When it comes to inert gas system operation.
And it really highlights the importance of proper training.
Yeah.
And clear, detailed instructions for everyone involved in operating these systems.
Speaking of training, I noticed that the IMO guidelines really emphasize the need for both theoretical and practical training for crew members. It's not just about knowing how to flip a switch, is it?
It's not. You have to understand the why behind the procedures, the potential hazards, and how to respond quickly and effectively if something goes wrong.
Right.
It's all about building a culture of safety on board.
And that brings us to a crucial question that I think our listener might be wondering.
Sure.
With all these complexities and potential hazards,
right,
why not just require inert gas systems on all tankers?
That's a great question.
Regardless of size.
And one that the industry has been grappling with for years.
Yeah.
Historically, only larger tankers were required to have these systems.
Okay.
But as we've seen from the OCIMF report,
Right.
even smaller tankers can pose a significant risk if they're not properly equipped.
Right. And that report highlighted some pretty tragic incidents where the lack of inert gas systems led to fires and explosions, resulting in loss of life and environmental damage. It really underscores the importance of these systems.
It does. And the IMO has been gradually lowering the size threshold for mandatory inert gas systems over the years.
Okay.
But there are still many tankers out there, especially older vessels, that don't have them.
It sounds like a complex issue.
It is.
With a lot of factors to consider.
Right.
On one hand, you have the safety benefits of inert gas systems. And on the other hand, you have the costs and logistical challenges of retrofitting existing vessels.
Exactly. It's a balancing act, and one that will likely continue to evolve as technology advances and the industry gains a better understanding of the risks and the best ways to mitigate them.
Now, before we dive into the specific requirements and operational challenges of inert gas systems in part 2 of our deep dive, I want to leave you with a question to ponder. Given the compelling safety benefits we've discussed, should regulations mandate the use of inert gas systems on all tankers, regardless of size?
Yeah.
Why or why not?
It's a question worth considering as we continue our exploration of this vital maritime technology.
Absolutely. All right, so think about that. We'll see you next time for part 2.
Sounds good.
Of our deep dive into inert gas systems.
Okay.
See you then.
See you later.
Welcome back to our deep dive into the world of inert gas systems.
Yes.
We've laid the groundwork understanding the why behind these systems.
Right.
Now let's get into the how.
Okay.
The specific rules and guidelines that make these systems so effective.
Sounds good.
That's where our next source comes, in the International Code for Fire Safety Systems, or FSS code for short.
Okay.
It's like the instruction manual for building and operating a safe inert gas system.
Right.
So if the IMO sets the overall safety goals, the FSS code provides the detailed blueprint for achieving them.
Precisely. Chapter 15 of the FSS code dives deep into the technical specifications.
Okay.
Covering everything from power supply requirements to alarm placement.
Wow.
It's all about ensuring these systems meet the stringent safety standards set by the IMO.
So it's not just about having the equipment.
Right.
It's about making sure it's designed, installed, and operated correctly.
Yes.
And the FSS code lays out all those nitty-gritty details.
Exactly. Remember how we talked about the 8% oxygen limit in the inert gas main?
Yeah.
Well, the FSS code spells out how you achieve that.
Okay.
It covers things like automatic control systems and the frequency of oxygen level monitoring.
So it's like a constant watchdog.
Right.
Making sure the system is always operating within those safe parameters.
But what happens if something goes wrong?
Right.
I mean, what if the oxygen level creeps above that 8% limit?
Yeah, that's what I was thinking. What happens then?
That's where those alarms we mentioned come in.
Right.
Section 2.4.3.1 of the FSS code is very specific about the requirements for audible alarms and automatic shutdown of the inert gas blowers if the oxygen content gets too high.
So like a safety net.
Right.
That kicks in.
Yes.
To prevent a potentially dangerous situation.
Correct.
Okay, that makes sense. But who's responsible for making sure all these rules and regulations are being followed?
Okay.
I mean, these tankers are sailing all over the world.
You're right, and that's where things get interesting.
Okay.
The enforcement of these regulations falls on the shoulders of flag states and port states.
Flag states, port states.
Yeah.
Can you break that down for me?
Of course, a flag state is the country where a ship is registered.
Okay.
It's their responsibility to ensure that the vessel complies with international regulations, including the FSS code.
Okay.
Then you have port states.
Right.
The countries where a ship docks.
Okay.
They also have the authority to inspect vessels and verify that they're meeting safety standards.
So there's this whole network of oversight, making sure that tankers with inert gas systems are operating safely wherever they go in the world.
Exactly. It's a collaborative effort to maintain a high level of safety across the global shipping industry.
Okay. I see. Now, I was also intrigued by this section in the FSS code on instruction manuals.
Yeah.
It seems like every tanker with an inert gas system needs to have a detailed guide on board.
Absolutely. Think of it like the ship's Bible for the inert gas system.
Okay.
Section 2.4.4 of the FSS code is very clear about what needs to be included.
Okay.
A clear line drawing of the system,
Mm-hmm.
a description of every component,
Right.
and step-by-step guides for various operations.
Okay.
It's like a training manual in itself.
So even if a crew member is new to the ship,
Right.
they can easily access all the information they need to understand the system
Yes.
and operate it safely.
Exactly. It ensures that everyone on board, from the captain to the newest crew member,
Right.
has access to that vital information.
And speaking of training, the FSS code also emphasizes the importance of ongoing training and drills, right?
Absolutely. It's not a one-and-done situation.
Right.
Crew members need regular refreshers on those safety procedures,
Right.
especially given the complexity of these systems.
Yeah, it's like anything else. If you don't practice and stay sharp, you can get rusty.
Yeah.
But instead of forgetting how to ride a bike,
Yeah.
you might forget a crucial safety step that could have serious consequences.
Exactly. Regular training and drills are essential to maintaining a culture of safety on board
Right.
and ensuring everyone knows how to respond quickly and effectively if something goes wrong.
So we've got the regulations, the technical specifications, the training. It's all starting to come together.
Yeah.
But what about the actual operation of these inert gas systems?
Okay.
What does it look like in practice?
That's where Section 5 of our IMO source, MSC Circ.353, really shines.
Okay.
It breaks down the various procedures involved in maintaining a safe, inert atmosphere
Right.
in those cargo tanks during every stage of the voyage.
Okay, so let's walk through those stages. What happens first?
Well, imagine the tanker arriving at a port to load crude oil.
Okay.
The cargo tanks are empty.
Mm-hmm. But they're full of air.
Right.
That's where the process of inerting comes in.
Okay, so that's the first step, replacing the air in the tanks with inert gas
Right.
to create that safe, non-flammable atmosphere.
Precisely. The crew carefully introduces inert gas into the tanks, gradually displacing the air until the oxygen level is below that crucial 8% limit.
Okay.
It's a delicate process because you want to avoid any sudden pressure changes that could damage the tanks.
It sounds like there's a lot of precision involved
Yeah.
in operating these systems.
There is, and it doesn't stop there.
Okay.
Once the tanks are inerted,
Mhm.
they need to be maintained in that condition throughout the voyage.
Okay.
That means constantly monitoring the oxygen levels,
Right.
adjusting the flow of inert gas,
Mhm.
and dealing with any changes in pressure or temperature.
So it's not a set it and forget it kind of system.
Yeah.
It requires constant attention
Right.
and adjustment.
Exactly, and those adjustments become even more critical during cargo operations.
Yeah. So, for instance, during loading,
Right.
you have to carefully control the flow of inert gas
Mm-hmm.
to prevent any pressure buildup in the tanks
Right.
as the oil comes in.
And I imagine unloading is equally challenging.
It is.
You need to make sure you maintain that positive pressure in the tanks
Right.
to prevent air from being sucked back in
Right.
as the oil is pumped out.
You got it. It's a delicate balancing act to ensure a safe and efficient cargo operation.
Right.
And then there's tank cleaning, which is a whole other story.
Okay, let's talk about tank cleaning. Why is it so important, and how does it tie into the inert gas system?
Well, think about those massive cargo tanks.
Yeah.
Over time, they accumulate residue from the oil,
Mm-hmm.
which can affect the quality of future cargoes.
Right.
So they need to be cleaned periodically.
But isn't that incredibly dangerous? I mean, we've been talking about how flammable those oil vapors are.
It can be, which is why the inert gas system plays a vital role in tank cleaning.
Okay.
Before anyone can enter a tank, it needs to be thoroughly cleaned and gas-freed,
Mm-hmm.
meaning the inert gas is replaced with fresh air.
So it's like reversing the inerting process
Exactly.
we talked about earlier.
But it has to be done very carefully,
Right.
following strict procedures outlined in the IMO guideline
Right.
to ensure that the tank is completely free of flammable vapors and safe for entry.
I'm guessing those portable gas detectors we talked about earlier
Yes.
are absolutely essential for this process.
You bet no one should ever set foot in a tank without those readings confirming that it's completely gas-free and safe to breathe.
Now, I was reading about a procedure called crude oil washing.
Yeah,
It sounds a bit messy,
it is.
but it seems to be a key part of tank cleaning on many tankers.
Crude oil washing is a very efficient way to remove those stubborn oil residues from the tank walls.
Oh,
Using crude oil itself.
hold on. You're using oil to clean oil.
I know, right?
How does that work?
It's based on the principle that oil dissolves oil. They use high-pressure jets of crude oil to dislodge the residue, and then the mixture is pumped out of the tank.
That's pretty clever, but it sounds like it could be even more hazardous than regular tank cleaning.
It can be, which is why it requires an even more precise control of the inert gas system. You have to maintain a very specific balance of inert gas and crude oil to ensure that the atmosphere inside the tank remains non-flammable throughout the washing process.
It sounds like there's very little room for error.
There isn't Section 5.6 of MSC Circ. 353 lays out the specific requirements for crude oil washing, including the frequency of oxygen level checks and other safety precautions.
Wow.
It's a testament to how complex these systems are and how much attention to detail is required to operate them safely.
So we've covered inerting, purging, gas-freeing, and even crude oil washing.
Right.
It's amazing how much goes into maintaining a safe atmosphere inside those cargo tanks.
And it highlights the crucial role of the inert gas system in every aspect of tanker operations.
Now, before we wrap up this part of our deep dive, I want to shift gears slightly and talk about something that's equally crucial to the safe operation of these systems. Maintenance.
Yes.
I mean, like any complex piece of machinery, these systems need regular checkups, right?
Absolutely. Regular maintenance is the key to keeping these systems operating safely and reliably. And Section 9 of MSC Circ. Tort 353, which we've mentioned before, provides a comprehensive overview of the inspection and maintenance routines that are essential for these systems.
Yeah, so what kind of things are we talking about here?
We're talking about regular inspections of those scrubbers, blowers, and non-return devices.
Right.
You need to make sure everything is free of corrosion, debris, and any other potential problems.
So it's not just about making sure the system is working.
Right.
It's about preventing problems before they even occur.
Exactly. And it's not just about visual checks. We also need to regularly test those alarms, pressure gauges, and oxygen analyzers to ensure they're calibrated correctly and functioning as intended.
It sounds like a pretty expensive checklist.
It is, but it's essential to ensuring the reliability and safety of the entire inert gas system.
Right.
Just like with your car. Regular maintenance can prevent much bigger problems down the road.
And in this case, those bigger problems could be catastrophic.
Exactly. The consequences of a failure in the inert gas system could be devastating.
So it all comes back to that core principle of safety.
Right.
The regulations, the procedures, the maintenance. It's all about protecting lives and the environment.
Absolutely. And that's a responsibility that everyone involved in the shipping industry takes very seriously.
Yeah.
Inert gas systems are a vital part of fulfilling that obligation.
Now, as we head into the final part of our deep dive, I'm curious to explore some of the alternatives and innovations that are shaping the future of inert gas systems.
All right.
Are there other ways to achieve that same level of safety? What's on the horizon for this technology? Let's find out. Welcome back. We've covered a lot of ground exploring the ins and outs of traditional inert gas systems.
We have.
But as with any technology, things are always evolving. So what's next for these systems?
Okay.
Are there other ways to create that crucial inert atmosphere on board tankers?
You're right. The world of maritime safety is constantly innovating. While flue gas systems have been the workhorse for decades, there are some exciting alternatives emerging, driven by the need for even greater safety efficiency and environmental responsibility.
Okay, color me intrigued. What are some of these alternatives?
One word, nitrogen.
Nitrogen.
Nitrogen generators are becoming increasingly popular, especially on tankers carrying sensitive cargoes.
Nitrogen, like the stuff that makes up most of our atmosphere.
Exactly, and that's one of the biggest advantages of nitrogen generators. They extract nitrogen directly from the air, meaning you have a readily available and sustainable source of inert gas.
That sounds pretty convenient.
It is.
Especially compared to relying on the ship's boilers for flue gas. But how do these nitrogen generators actually work?
They use a process called membrane separation, or pressure swing adsorption, to separate nitrogen from the other gases in the air, like oxygen. It's a bit technical. But essentially, these systems act like high-tech filters, allowing nitrogen to pass through while trapping the other gases.
So you end up with a stream of pure nitrogen that can be used to inert the cargo tanks.
And the beauty of nitrogen is that it's incredibly pure. Much more so than flue gas. You don't have to worry about those contaminants like sulfur dioxide or particulate matter that we talked about earlier.
So cleaner gas.
Yes.
Which is great for protecting cargo quality. Especially for those sensitive cargoes you mentioned.
Plus, nitrogen generators offer a greater degree of flexibility and independence. They're not tied to the ship's boilers, so you can generate inert gas whenever you need it, regardless of whether the boilers are running or not.
That sounds like a significant advantage.
It is.
Especially in situations where you might need to quickly inert a tank or maintain a positive pressure for an extended period.
Precisely. And in the event of a boiler failure, you still got that vital inert gas supply available, adding an extra layer of safety.
Okay, nitrogen generators sound pretty impressive.
They are.
But are there any downsides? I mean, every technology has its trade-offs, right?
Of course, nitrogen generators require a dedicated power source.
Okay.
And they do add complexity to the overall system. They also need regular maintenance to ensure they're operating efficiently.
So it's a balancing act for ship owners, weighing the benefits of cleaner gas and operational flexibility against those additional costs and complexities.
Exactly. Each ship owner has to make that decision based on the specific needs of their vessel and the types of cargoes they carry.
Now, beyond the source of inert gas, are there any other innovations happening in this field?
Sure.
Any cool new technologies on the horizon?
Absolutely. One area that's really exciting is the development of more sophisticated monitoring and control systems.
I can see how that would be important.
Yeah.
We talked about the need for precise oxygen level control. And those manual checks can be time-consuming and prone to human error.
Exactly. So the industry is moving towards more automated systems that can continuously monitor oxygen levels, pressure, and other critical parameters in real time.
So imagine sensors throughout the tanks constantly feeding data back to the crew, giving them a clear picture of what's happening inside those tanks at any given moment.
Exactly. And these systems can be integrated with alarms and automatic shutdown mechanisms, providing an extra layer of safety by responding immediately to any deviations from the safe operating parameters.
That sounds like a huge step forward in terms of risk mitigation.
It is, and there's also a lot of research going into new types of non-return devices that are more reliable and easier to maintain.
Oh, okay.
Remember those deckwater seals we talked about?
Yeah.
They're effective, but they do have some limitations.
Right. They require constant water supply and can be prone to freezing in cold weather.
Exactly. So engineers are exploring alternative designs that might use membranes or other advanced materials to create that crucial barrier against backflow. The goal is to develop a system that's even more reliable and less susceptible to those environmental challenges.
It sounds like the future of inert gas systems is all about automation efficiency and even greater reliability.
It is.
All in the name of keeping those tankers sailing safely.
It's a testament to the ingenuity of the maritime industry and its commitment to continuous improvement.
And it's really inspiring to see how technology is being used to enhance safety and protect both human lives and the environment.
Absolutely. It's a reminder that innovation and safety go hand in hand in the maritime world.
Well, we've covered a lot of ground in this deep dive, exploring the past, present, and future of inert gas systems on tankers.
We have.
We've seen how they work, why they're so vital, and the incredible amount of thought and engineering that goes into making them safe and effective.
A lot of work goes into it.
And we've touched on some of the challenges and the exciting innovations that are shaping the future of this technology.
Yes.
And remember that question we posed earlier about whether inert gas systems should be mandatory on all tankers regardless of size.
Right.
We've given you the information, the context, and the different perspectives to ponder that question.
A lot to think about.
It's a complex issue with no easy answers. But it's a conversation worth having.
It is.
As we continue to strive for a safer and more sustainable maritime industry.
Absolutely.
So keep exploring, keep asking questions, and keep learning. After all, the more we understand about these vital systems, the better equipped we are to make informed decisions about the future of tanker safety. Until next time. Thanks for joining us on this deep dive.
See you later.